automotive industry has been changing rapidly over the past few years. One of the biggest changes, alongside the introduction of electrification, seems to be connectivity. All vehicles are now connected. Joining me today is Siemens Automotive IC Test Solutions Manager, Lee Harrison. Lee, how do you see the developments in vehicle connectivity impacting the challenge of vehicle security? And what are the risks and what regulations are being put in place?
The introduction of connected vehicles is absolutely massive. And the implications that has on the technology, what we can do with the vehicles now, what the expectations are, and the sort of applications that we can apply to these connected vehicles. I feel that we're only really just starting to scratch the surface of what's possible. And in terms of what impact this has on security is again, it's absolutely huge, because if you think back to before when vehicles were connected, if someone wanted to attack a vehicle, it was one attacker, one vehicle, and the attacker had to be there in person. Now with this connectivity, the landscape for attacking vehicles is absolutely huge, and it can all be done remotely. And now the attacker has the ability not just to attack one vehicle at a time, but could potentially impact the operation of a whole fleet of vehicles at a time. So that compounded for the automotive OEMs is absolutely huge. So it's really important that they get the security right and address it up front. And I think what we've seen over the last couple of years, we've seen the introduction of a few standards and regulations. From the OEM's perspective, we have the UN ECE WP29, which really defines requirements around what automotive OEMs have to do to be able to deliver over-the-air updates to their vehicles. And then falling back on that, for the rest of the supply chain, we have the new standard, which is the ISO 21434, which really governs the whole cybersecurity aspect of how do we design that into the actual vehicle systems itself. So that ISO standard combined with the UN ECE really kind of is starting to mandate what's required in terms of security within vehicles.
You have an extensive portfolio of technology in the IC space. What type of solutions have you been looking at to address these challenges?
The technology that we've been driving with those customers for a number of years has been really focused around the quality of manufacturing test. So producing electronics and ICs that are zero defects that go into vehicles. Over the last few years, the requirements around safety has mandated that we now need to be able to test those ICs in system, so be able to run additional tests and make sure that not only are the devices that we deliver at time zero are defect free, but throughout the life cycle of the vehicle they continue to be defect free. And then moving more to the future, what we're starting to see now with the addition of security and cyber security, we're now having to introduce technologies to be able to check for anomalies that are going on in the vehicle. So rather than looking for defects that occur in the silicon, we're starting to look kind of at an abstracted level up and where the functionality goes wrong. So and like I said, we've got a whole range of technologies now that cover everything from manufacturing test, in-system test, the safety side of things, and now we've got our embedded analytics technology that really focuses on the cybersecurity aspects of things.
And there are lots of software solutions in the market. Your hardware-based approach is slightly different. What do you think are the advantages of a hardware solution?
Yeah, so I mean, every security solution that goes into a Siemens product follows kind of a mandate of being a multi-layered security system, and Siemens refers to that as defense in depth. Obviously, software plays a big part in that, but with the embedded analytics technology, we go right down into the nuts and bolts of the actual silicon itself, and instead of kind of monitoring software transactions, we're monitoring hardware transactions on a physical bus or a physical memory. So really the embedded analytics technology is right down at the lowest level and it's embedded in the hardware, so can't directly be hacked itself. Obviously, we're going to need layers on top of that, which will potentially include software, but it's building up that complete stack of security technologies that's important. The hardware security is actually built into the silicon on the chip, so there's nothing you can do to work around that or to impact that directly.
And you've spoken about a number of different types of technology. Can you just let me know what are the advantages of having alignment between these technologies?
So at Siemens, as I said, we've got a whole range of technologies. Certainly on the testing side, everything covering manufacturing test, in-system test, safety, and now the embedded analytics technology for monitoring the functional operation. Now, each of those technologies brings a huge value, but if you're able to manage all of those technologies together and have a common infrastructure between all of them, the resulting advantage is bigger than the sum of all the parts. So really, being part of Siemens, we've got this advantage. We're able to pull all that stuff together and have a completely integrated solution. So giving our customers and automotive IC designers pretty much a complete off-the-shelf solution.
And let's look to the future. How do you see this thirst for connected data changing, and where do you think we might see the application of this data being applied where it isn't today?
So I think, as I said at the beginning, my feeling is that we've only really just scratched the surface of what we can do with this. The amount of data and the type of data that we can start to extract from vehicles once we have this technology on board is absolutely huge. And there's already a huge amount of work across the industry starting to look at things like reliability modelling, preemptive servicing. So really trying to reduce the amount of downtime the vehicles have. And that crosses over into the other discussion about what is the vehicle use model going to be in the future. And I know that's a topic we can talk about for hours, where are we going to move away from the vehicle ownership to pay per ride, and then if we do go in that direction, then keeping down the vehicle downtime and maximising the vehicle's profitability is going to be key. So as you can imagine, there's a huge interest in that, and I think one of the drivers is at the moment there is an expectation in terms of the lifetime of the electronics and how long it will last without failing, and that's about 10,000 hours, and for a personally owned vehicle that's more than adequate. But if you go to the pay per ride model where the vehicle's in constant use, that 10,000 hours gets burned up pretty quick. So the reliability modelling and making this technology last longer is again, it's really key to success. The automotive industry as a whole is, if you look back over the past years, is generally a pretty conservative industry. What we're seeing now is an absolute explosion in technology, advancements, and even the whole supply chain is changing in its structure. So, and if you look at where the innovation is coming from, there's lots and lots of new automotive companies appearing from nowhere, and I think there's going to be at least another good 10 years of change before things start to settle down again, and during that time there's going to be a huge amount of really smart technology come out of that.